Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0221 signifies that the throttle position TP sensor B is out of range. This particular error is crucial because the throttle position sensors are essential for managing the air-fuel mixture and overall engine performance in the Honda CRV. The TP sensor B is typically located on the throttle body assembly, which is situated between the air intake and the engine. This sensor helps monitor how open the throttle plate is, providing real-time feedback to the engine control module, ECM. If the signals from the TP sensor B fall below or exceed specified voltage thresholds, it can lead to performance issues, including engine stalling or reduced power. Understanding this code's implications allows technicians to identify and resolve potential malfunctions, ultimately ensuring optimal vehicle operation. The DTC P0221 indicates a malfunction specifically involving the TP sensor B, a critical component in the throttle system. The primary role of this sensor is to monitor the angle of the throttle plate, ensuring the ECM can adjust the air and fuel supply accordingly. It is located on the throttle body assembly, a key part installed between the air intake and the engine. This sensor's output is measured in voltage, and its readings help the ECM make real-time adjustments to improve engine performance and efficiency. If the TP sensor B reports a voltage lower than 0.48 volts or higher than 4.61 volts, it demonstrates that the system is out of range, prompting this DTC to trigger. Understanding the significance of the TP sensor B is crucial for diagnosing and rectifying issues related to engine performance and drivability. Several potential causes can lead to the triggering of DTC P0221, each presenting its unique challenges. First, a faulty TP sensor B may produce incorrect voltage readings, which can cause the DTC to activate. Secondly, wiring issues, specifically in the TL2 line, such as shorts or opens, can disrupt communication between the throttle body and the engine control module, ECM. Additionally, loose or corroded connections at various junctions, including the throttle body and the powertrain control module, PCM, can lead to intermittent issues that may trigger this DTC. By identifying these potential causes early in the diagnosis process, technicians can focus their efforts on the most likely sources of the problem, thus streamlining repairs and restoring functionality to the vehicle. The presence of DTC P0221 can manifest itself through several noticeable symptoms that impact overall driving experience. Poor engine performance is often one of the first signs, resulting in sluggish acceleration or erratic idling, indicating that the engine is not receiving correct throttle position input. This can sometimes lead to engine stalling, particularly at low speeds, which poses a safety concern for drivers. Additionally, there may be a noticeable reduction in throttle response, making the vehicle less responsive when the gas pedal is pressed. If left unaddressed, these symptoms can adversely affect not only the vehicle's performance, but also its safety and reliability on the road. Awareness of what to look for is crucial for both technicians and drivers. In the first troubleshooting step for DTC P0221, the process begins by turning the vehicle to the on mode, a preliminary action crucial for activating the onboard diagnostic system. Next, use the Honda Diagnostic System HDS to clear the current DTC. This step is vital because it resets the ECU and allows for fresh readings of the vehicle's parameters, relocating any persistent issues. After clearing the DTC, check the signals for TP sensor B using the HDS. This is done by measuring the voltage output against specified threshold values. If the voltage falls below 0.48 volts or exceeds 4.61 volts, it confirms that the DTC is indeed valid and requires further investigation. If the conditions match the threshold satisfactorily, the failure duplicates, indicating a direct issue that needs resolution. In this second troubleshooting step, check the output voltage of the TP sensor B again using the HDS. Specifically, look for values exceeding 4.61 volts, as this can signify an out-of-range condition indicative of the malfunction. If the conditions match this threshold, it suggests a consistent issue, prompting further examination. However, if the readings are within the acceptable range, then the failure may be intermittent or transient in nature. In such cases, it is necessary to investigate potential causes such as poor connections or loose terminals that could disrupt the signal between the throttle body and the ECM. Using an onboard snapshot can also help replicate the conditions during which the DTC originally appeared, allowing for more focused troubleshooting efforts. By examining these connections, technicians can uncover hidden faults that may not be immediately visible. During troubleshooting step 3, it's essential to check for both pending and confirmed DTCs using the HDS. This step helps determine if other related trouble codes, such as DTC P0121 for TP sensor A, are flagged concurrently. If both DTC P0121 and P0221 are indicated simultaneously, it can signal a more systemic issue affecting multiple sensors. In this case, the troubleshooting steps would shift focus towards evaluating one of the components to isolate the cause. Conversely, if only DTC P0221 is present, further examination will target the throttle body and associated circuitry. Understanding the interdependence of these sensors is vital for precise diagnostics, streamlining the troubleshooting process by allowing technicians to pinpoint the failure area effectively. In troubleshooting step 4, turn the vehicle to the off/lock mode to ensure the system is in a safe state for further electrical testing. Utilizing the HDS, jump the SCS line and wait for more than 1 minute. This step is crucial for ensuring that the diagnostic system is reset and that any faults present can be accurately assessed. Next, disconnect the necessary connectors, the PCM connector E, 80P, and throttle body 6P connector. The next action is to test the continuity between specified test points within the circuit. This involves checking if there is continuous electrical flow between the throttle body connector and body ground while keeping the vehicle in the off mode. If continuity is observed, it indicates a short in the THL2 wire, necessitating a repair between the PCM and the throttle body. If there's no continuity, further investigation is warranted without assuming the wire is faulty. The fifth step involves assessing the voltage being sent to the throttle body to determine if it operates within the expected parameters. First, ensure the vehicle is turned off before disconnecting the throttle body's 6P connector. After disconnecting, turn the vehicle to the on mode. This action is necessary to gauge whether the throttle body is receiving proper voltage. Measure the voltage at the designated test points between the throttle body connector and body ground. Specifically, the expected voltage should be approximately 5.0 volts. If this reading is confirmed, it indicates that the throttle body is functioning properly, yet may still require replacement if other diagnostics point to further issues. On the contrary, if there is no appropriate voltage, then the next steps will be needed to further diagnose connected components, ensuring that troubleshooting remains systematic and detailed. In the sixth troubleshooting step, focus shifts to checking the VCC3 line for potential open circuits that could disrupt communication between the throttle body and the PCM. Start by ensuring the vehicle is switched off before proceeding to disconnect the PCM connector E, ADP. After disconnection, test for continuity between the specified test points at the throttle body and the PCM, while the vehicle remains in the off mode. This test checks whether there is an electrical break in the VCC3 wire, which can lead to erratic signals or no signals at all. If continuity is present, it may indicate that the VCC3 wire is functioning as intended. In cases where continuity is absent, repairs must be made to the wire, depending on the precise location as identified through thorough diagnostics. This methodical testing helps ensure that each electrical pathway is scrutinized. Step 7 calls for another check for both pending and confirmed DTCs using the HDS. Just like in previous steps, determining if DTC P0121 and P0221 are both present can provide additional insights into potential systemic issues. If these DTCs appear simultaneously, it indicates that there may be a collective failure impacting multiple systems related to throttle position sensing. This necessitates a careful review of the situation, often requiring in-depth examination of the throttle body and the relevant ECU components. If only DTC P0221 remains, focus can pivot back to evaluating other relevant components for additional faults. Awareness of how these components interact allows for more effective diagnostics, ultimately aiding in maintaining the vehicle's optimal performance and safety. In troubleshooting Step 8, the protocol once again requires disconnecting the throttle body 6P connector to measure voltage accurately. Ensure the vehicle is in the off mode before disconnecting, and then switch the vehicle back to the on mode for measurement. At this point, voltage should be closely examined between specified test points on the throttle body and body ground. The expected reading remains around 5.0 volts. If this voltage is confirmed, then replacement of the throttle body is warranted. If the voltage deviates from this expected value, it signals further issues that necessitate additional testing protocols to narrow down the exact problem. This step is vital for isolating the throttle assembly as a potential point of failure. During troubleshooting Step 9, the process shifts back to evaluating the THL2 line for potential wiring integrity issues. Again, turn the vehicle to the off mode and disconnect the PCM connector E, ADP. Conduct a continuity test between the throttle body and the PCM connector while ensuring both connectors are removed. This test will identify if there is continuity through the THL2 wire, which transmits the throttle position signals. If continuity exists, the wire is deemed functional, and further diagnosis may involve other components like the PCM itself. Conversely, if there is no continuity present, this signals a break in the wire requiring repair. This methodical approach ensures comprehensive diagnostics, allowing technicians to maintain an effective workflow. The final troubleshooting step focuses on evaluating the SG3 line for any open circuits that may disrupt the throttle control functions. Begin by ensuring the vehicle is in the off lock mode, followed by disconnecting the necessary connectors on both the PCM and throttle body. With these connectors properly disconnected, check for continuity across test points between the throttle body connector and the PCM. If continuity is verified, it means the SG3 wire is functioning well and points towards other potential issues needing attention. However, if continuity is missing, it indicates an open circuit which must be repaired in the SG3 wire between the PCM and the throttle body. Such systematic troubleshooting ensures a clear understanding of the vehicle's wiring and systems, leading to an effective resolution. Final verification is an essential part of the diagnostic repair process, ensuring that the prior troubleshooting measures were effective. Begin by rechecking for DTC P0221 using the HDS, which confirms whether the previously identified issue has been resolved. After clearing any previous DTCs, it's crucial to test the throttle operation while observing if all values fall within acceptable parameters. This additional inspection guarantees that no other errors have emerged during the repair. A successful recheck will yield no additional trouble codes, confirming that the previously identified issues have been resolved and the vehicle operates effectively. Verification not only assures the technician of the accuracy of repair, but also instills confidence in the vehicle's safety and performance for the driver. Preventive maintenance is key to ensuring long-term reliability and performance of a vehicle, particularly in relation to critical components such as the throttle position sensors. Regular inspection of electrical connections, specifically at the throttle body and PCM, can prevent intermittent failure due to corrosion or loosened terminals. Monitoring throttle response can help identify potential issues before they escalate into severe DTCs like P0221. Additionally, keeping sensors clean and free from debris can enable accurate readings, improving overall engine performance. Scheduling routine maintenance checks and ensuring that all wiring is intact will greatly reduce the risk of unexpected failures, resulting in a smoother and more efficient driving experience. In summary, DTC P0221 signifies a critical issue with the TP sensor B, impacting engine performance. The systematic troubleshooting steps outlined provide a structured approach to diagnosing and rectifying the underlying causes of this error. By checking parameters, evaluating wiring integrity, and verifying sensor functionality, technicians can pinpoint issues and implement appropriate repairs effectively. Additionally, the importance of preventive maintenance cannot be overstated. Regular inspections and the monitoring of connections and performance can significantly reduce the likelihood of recurring errors. Through a combination of thorough diagnostics and proactive maintenance strategies, vehicle reliability can be ensured, fostering a safer and more efficient driving environment. Please like and subscribe to the channel. See you next time.